Welcome back to Underground Science, and in this video we'll be talking about naming cycloalkenes. Okay, so if you remember from cycloalkanes, if I were to draw this, right, just a simple, what is this? This would be a cyclohexane, right? And remember, in our previous videos, we've been naming alkenes, right, just not cyclic compounds. But in alkenes, like if we drew this, that would be butane, right? And then if you remember, if we just add a double bond, it would be butene, okay? Same thing goes for cyclic compounds. So right now we have cyclohexane, but if I were to say, okay, I'm going to add a double bond here, this would now be cyclohexene, all right? And same thing goes with the other cyclic rings. So if I were to draw this right here, what would you say that would be? That would be a cyclopentane ring, right? But if I were to draw a double bond here, that would be a cyclopentene ring. So this would be a cyclopentene ring. And if I were to draw like two more examples, if I were to draw this, that would be a cyclobutane ring, right? But if I were to draw a double bond, that would be a cyclobutene ring. So let's go and write that down. Cyclobutene ring. And last but not least, if I were to draw this, that would be a cyclopropane ring. But if I were to draw a double bond here, that would be a cyclopropene ring. So cyclopropene ring. All right. Now that we went over the common rings, the common cycloalkene rings, right? Let's go ahead and dive into examples. So this is going to be our first example. And in this example, again, let's start by numbering the longest carbon chain, which will be in the ring. So if we, but also remember, we need to number it so that the double bond is in the least carbon. In a ring, right, in alkenes, the double bond gets priority, okay, not the substituent. So we can't, so you would think, okay, let's make the substituent the least carbon number, right, like we did for alkanes. So you would want to number it like this, because then, right, then the substituent gets 1, which is the least carbon number. But in alkenes, you give the double bond preference. So for that, right, so let's go and fix this. So for this, you would actually want the double bond to be on the least carbon. So you would start numbering here. 1, 2, 3, 4, 5, 6. Right, so now the double bond has a least carbon 1, and then the substituent falls after that. Okay, so now that we've numbered this, how would we name it? So first, identify the substituents. Well, we only have one substituent. What is this called? It's a cyclopropane ring, but since it's a substituent off a parent chain, it would be a cyclopropyl substituent. So this would be a cyclopropyl substituent. And it's because it's cyclo. Why? Because it's in ring format. So how would we name this? Well, the double bond is on the 1 carbon, and we have a substituent on the 4th. So let's go and name the substituent first. So we use 4-cyclopropyl, and then we have the substituent on the 1 carbon, so it'd be 1. And then what is this molecule called? It's a cyclohexene, right? Because it's 6 carbons, and it's in cyclic form, and it's an alkene, so it'd be 1-cyclohexene. Now, of course, you could have wrote this, you could have just said cyclohexene. So what I mean by that is let's write it underneath, okay? 4-cyclopropyl. But because there's only one double bond, right? So you don't have to say 1-cyclohexene, like it's already known it's going to be on 1, because there's only one double bond to worry about. So you could just say 4-cyclopropyl and then cyclohexene. Okay, you could say either way, whichever way it works. Okay, let's say we had this example, right? So this is similar to the last one, so let's get more practice with this. How would we number the carbon? Would we want to give the substituent the least number, or would we want to give the double bond the least number? So remember, in alkenes, give double bond the least carbon number, okay? So we would start here. 1, 2, 3, 4, 5, 6. Now you may be wondering, okay, but if we start here, right, if we start at this carbon 1, that's also the least we're also giving the double bond the least carbon number, which is 1. But if you check this way, what actually happens is, if we check the blue numbering, the carbon number in which the double bond falls on is 1, but then the carbon number that the substituent falls on is 5. Okay, so if you do the same thing for the red numbering, the carbon number that the double bond falls on is 1, so it's a tie there, but then you have to look at the substituent next if it's a tie. And for the red numbering, the substituent falls on carbon number 4. So that's why the red numbering actually wins. So now that we know that, let's just name the molecule. So what substituent is this? This is an isopropyl off of what carbon? The 4th carbon. So let's go and write that down. So it'd be a 4-isopropyl. And then what carbon is a double bond on? The 1st carbon. So we don't have to say anything, right? We don't have to say 1-cyclohexene. We can just say cyclohexene. Or if you wanted to just to be safe and specific, you could say 1-cyclohexene, but you don't have to. Okay, so if we said 1-cyclohexene, remember for IUPAC rules, right? You can also, so this would be the correct way. Then if you kept this all the same and just said, instead of saying 1-cyclohexene, you just said cyclohexene, right? That would be also correct. And if you said 4-isopropyl, right? And instead of saying 1-cyclohexene, you said cyclohex 1-ene, that would also be correct. All right, so all 3 forms are correct. Okay, let's look at this example now. Now we're dealing with the halogen. Okay, bromine is a halogen. So same exact rules. It's still a substituent, right? So you would still give the double bond priority. So if we started here, right, 1, 2, 3, 4, 5, 6, but then if you wanted to start the other way, you could also say 1, 2, 3, 4, 5, 6. Who wins? So for the red numbering, the double bond is on carbon number 1, but the substituent bromine is on the carbon number 4, right? But for the blue numbering, the double bond is on carbon number 1, so that's a tie. Now we look at the substituent, and for the blue numbering, the bromine substituent is on carbon number 5. So that means the red carbon number pattern, right? The red carbon numbering pattern wins. So now that we know that, let's just name the molecule. So if we have a halogen substituent, instead of calling it bromine, we would, since it's bromine, right? It's bromine off a parent chain. Sorry, off a parent chain. So it wouldn't be bromine, it would be a bromo substituent. Okay? All right, so now that we know that, let's name the whole molecule. So what carbon number does the double bond fall on? 1, right? And what carbon number is the bromine substituent or the bromo substituent coming off of? 4. So it'd be 4-bromo, right? 4-bromo, and you could say cyclohexene because there's only one double bond, but if you want to be specific, you can say 1-cyclohexene. And again, if we're looking at IUPAC rules, you can also put the 1 in front of the cyclohex. So it'd be 4-bromo cyclohex, and then you can put the 1 designating that the double bond's on the 1 carbon. All right, so both of these are correct. All right, now let's look at this example. Same thing, let's start numbering it. So 1, 2, 3, 4, 5, 6. Remember, we're prioritizing the double bond first, so we want the double bond to be in the least carbon number, not the substituents. But you can also number it the other way, right? So 1, 2, 3, 4, 5, 6. Now, which way is correct? So let's go and compare. Red, the red numbering, at what carbon number is the double bond on? So 1, right? What carbon number is the bromine substituent on? 4. And what carbon number is the chlorine substituent on? 5. Okay, now let's go to the blue numbering. What carbon number is the double bond on? 1. What carbon number is the bromine substituent on? Number 5. And what carbon number is the chlorine substituent on? Number 4. Now this is kind of weird because either way you go, right, you have substituents on the 4th and 5th carbon. The question is, which one do we choose? Which numbering pattern? So if you look at the red numbering pattern, what's the least carbon number in which bromine falls on? Okay, or even before that, who comes alphabetically first, bromine or chlorine, right? So B comes before, right? B comes before C alphabetically, okay? So B wins alphabetically. So we focus on giving the alphabetical winner, bromine, the least carbon number. So look at the numbering now. For the red carbon number, so let's compare it twice again. So for bromine, that's the alphabetical winner, right? So for bromine, what carbon number, right, does bromine come off of? For the red carbon number pattern. So 4, right? So let's say that, 4. Now for the blue numbering pattern, at what carbon number does bromine come off of? That would be 5. So which carbon number, right, is less? 4. 4 is less than 5. So that would mean that the red carbon number pattern would be the one we would choose in order to name this whole molecule. So now that we know that, let's name the whole molecule, right? So what carbon number does the bromine substituent come off of? That's 4, right? So it'd be 4-bromo. And then chlorine comes off the 5th carbon, so it'd be 5-chloro. And then we have a double bond on the 1st carbon. So let's go and name the whole thing, and that is 4-bromo. And remember, we're naming in alphabetical order. So because bromine comes before chlorine alphabetically, we're going to name it 4-bromo first, then 5-chloro. Okay, then at what carbon is a double bond on? Well, you don't have to say this, but if you want to, we can. And that would be the 1st carbon, right? Because that's where the double bond originates, the 1st carbon. So it'd be 1 and then cyclohexene. Again, according to IUPAC rules, let's just do this. You can, everything till here will be the same. But after chloro, you can straight say cyclohex and then designate at what carbon number the double bond is. So in this case, it would be 1 and then ene. Okay, either way is correct. Or you can say this whole thing and then don't even say the dash 1 dash, and right away just say cyclohexene, since there's only one double bond. So any of these names, right, are correct. Last but not least, let's do this example. So now we're dealing with 2 double bonds in a cyclic ring. So again, let's start numbering this. But because there can be multiple ways of numbering this, 4 main ways that we're going to look at, let's divide it into 4. Okay, so if we started, remember we're trying to make the double bond the least carbon number. We're trying to designate the double bond to the least carbon number. So if we started the top left, if we started here, 1, 2, 3, 4, 5, 6, right? And then let's say we go, the other way we would name this, right, would be starting the 1 here. Because you wouldn't want to name it 1, 2. If you start the 1, right, if you start numbering 1 on one side of the double bond, 2 has to come right after. You can't skip this carbon because this carbon is part of this double bond, right? So 2 has to be part of the double bond. So the other way we'd name it is 1, 2, 3, 4, 5, 6. Okay, now if we come on this side, let's focus on this double bond. So we could name it 1, 2, 3, 4, 5, 6, or we could start on this carbon, 1, 2, 3, 4, 5, 6, right? And if we do that, now we compare, okay, which carbon number do we do? So let's compare the left side first. Now on the left side, right, at what carbon numbers, so for the top left, at what carbon numbers are the double bonds and the substituent on? So that'd be carbon numbers 1, 3, and 5, right? So then we look at the one below that, at what carbon numbers are the double bond and substituents on? So that would be carbon numbers 1, 5, right? So 1 and 5 is where the double bond is on. And then what about the substituent? So that'd be carbon number 4, right? So who wins between these two? 1, 3, and who's less is what I should say. 1, 3, and 5, or 1, 4, and 5, right? So 1, 3, and 5 is less. So that means we can get rid of this, right? We're not going to use this numbering pattern. Now let's compare the right side. So again, the top right, at what carbon numbers are the double bonds and the substituent at? For the double bonds, it would be at carbon numbers 1 and 3. And for the substituent, right, if we bring consistent, let's just say numbers 1 and 3. And for the substituent, the chlorine substituent would be at number, what? Carbon number 6. So we have 1, 3, let's separate this out. 1, 3, and 6 here. If we look at the one below that, we have the double bond, or the carbon, at what carbon numbers are the double bonds at? That would be 1 and 5, right? So let's do carbon numbers 1 and 5. And then at what carbon number would be the chlorine substituent at? That would be carbon number 3. So out of these two, who wins? Well, who's less? 1, 3, and 6, or 1, 3, and 5? So 1, 3, and 5 is less than 1, 3, and 6. So that's why this carbon numbering would be the one that we wouldn't use also. So now, who wins between these two? Because if we look at these two, right, this is 1, 3, and 5, is what we found out, and this is also 1, 3, and 5. But if we pay close attention, right, let's just focus on the double bonds for now. At what carbon numbers are the double bonds at for this molecule? So for the double bonds, it would be carbon number 1, right, and carbon number 3. What about here? At what carbon numbers are the double bonds on? So that'd be carbon number 1 and carbon number 5. So who's less? 1 and 3 or 1 and 5? It would be 1 and 3, right? So this would win. This carbon numbering pattern would win. So we could X this out. So now let's just focus on this numbering pattern and this molecule and then go on and name it. Okay, so what do we have? We have a 5-chloro group, right? And that's all the substituents we have. And we have the double bond at the 1 carbon, and we have a double bond at the 3rd carbon. So we would name this by starting with the substituents first. So it would be 5-chloro, okay? And where are the double bonds? 1, comma, 3, and then what do we have here? We have a 6-carbon ring. So that would be a cyclohexane, right? But we have 2 double bonds, and the prefix we use for 2 would be di. So we would say we have a cyclohex, right? Because it's a cyclic ring and 6 carbons. But then we have 2 double bonds, so it'd be hexadiene, right? And that's it for this video. Okay, so this was the basics of alkene naming, or cycloalkene naming, and in the next video, we'll also be naming alkenes, but more complicated problems relating to trans, cis, E, and Z stereoisomers. All right, so I'll see you guys in the next video.